There are popular magazines that publish science for a general audience, and then there are refereed journals that publish science for scientists. And what distinguishes these two is that in refereed journals, you have what's called peer review. Before anything is published in a refereed journal, the article will be reviewed by at least 2 reviewers, professionals in their field, and it'll be judged based on its scientific merit and on its writing quality. And only if it's approved by those experts in their field will it be published in the journal as something that's worth consideration by other scientists in the scientific community. Because these are being written for working scientists, articles published in refereed journals have a specific format. The format allows you to read the articles strategically, to not waste time, to jump to sections where you know you will find things. And that's partly because it's so expensive to publish something in this. Because you need 2 experts to review it before it's published, the space in these journals is extremely valuable. So that space is organized most often in what's called the IMRD format. So professional chemistry articles published in those refereed journals are written in what's called the IMRD format. And that stands for the different sections. The first section is the introduction. In the introduction, you identify what topic you're going to be exploring. You explain why it's important. You give background information. What do people already know about this topic? And then you say what your topic is what your experiment is going to contribute to this. So you kind of start out really general. You start out general and you get specific. You say, okay, here is, so really general to specific. You say, here's what people know generally, here's the idea generally, here's why it's important generally. And then you get specific. By the end of this, you're introducing your specific experiment, and you're saying, listen, this is what I'm going to do. This is how my my specific experiment is going to contribute to this general knowledge. So that introduction section starts at general, gets specific. In the next section, you stay specific, the method section. This tells people how you performed your experiment. Remember that experiments are personal experiences that you can give reliably to other people. Science is based on personal experiences, not on authorities. And those personal experiences that you can reliably give to other people are the experiments that you're writing about in these articles. In order for someone else to have that experience reliably, they have to know exactly what you did. And that's what you talk about in the methods section. You say what equipment you used. You say what order you used it in. You give all the minute particularities of an experiment. Oftentimes, to a general audience, this is the most difficult to read, the section of a research article that's most difficult to read, because it has all the weird names of equipment and all of the particularities of performing the experiment. But you can imagine that if you're a scientist wanting to replicate somebody's research or to build on it, this could be one of the most valuable sections. But it's a very specific section. Now you do that experiment and you get results, and those results, quantitative most often, but sometimes qualitative, are what you present in the results section. Oftentimes you can represent that data in tables or in graphs. But in the results section, you do not interpret the data at all. You just present it. And then finally, in the last section, in the discussion section, you interpret those results. Now, the discussion section starts out specific. You're interpreting the specific results in your experiment, but by the end of it, you want to become general again. You want to say what this implies, what the interpretation of this information, the interpretation of the results in your experiment, what that implies for the field as a whole, and what type of applications it might have. So notice that this IMRD format has almost what looks like an hourglass structure. It's sometimes referred to as an hourglass structure. Remember, hourglasses are those things that sort of have sand in them that runs through. Those are hourglasses, and this kind of looks like that because you start out general, go specific, you stay specific for a while, and then you start specific and go general in that discussion section. Also, notice how knowing this format and having everybody write in this format means that you can skip over irrelevant parts of articles and jump to parts of articles that are specifically relevant to your research. Let's say you don't know how to do an experiment, you want to try doing your own experiment, then you jump straight to the method section. Let's say you're just new to the field and you want to see how different experiments fit into things. Well, then you can just peruse the introduction section. Let's say you think somebody drew the wrong conclusions in their experiment. You want to try to draw other conclusions. Then you would look at the results. But let's say you're interested in how people have interpreted data in a field over time and how that interpretation has changed. Well, then you'd go to the discussion. So depending on what you're interested in, you can, because this is a standard format for these articles, you can read strategically and jump to the sections that are important for you. And so this is not only a writing tool, but this is also a reading tool. Now this is a rule of thumb. There are exceptions sometimes to this general format for specific journals. So if you're thinking of applying to a specific journal, before you send your submission in, make sure you look for what's called the information for authors. The information for authors. And that, you can search on the internet for the specific journal and look for the information for authors section, and that will tell you sort of how their articles fit into this format, how they relate to it, whether there are any deviations from it or things that you want to make sure you comply with before you send in your submission. One last thing is when you look at these journals stand apart from popular magazines because of all of the effort that's put in to peer reviewing them. But not all journals have equal prestige, and one thing you can kind of use to gauge the prestige of journals is something called an impact factor. The impact factor is, on average, how many times an article published in a journal was cited. So how many times is an article published in this journal cited? So for example, if you have an impact factor of 2, that means on average every article in this journal is cited by 2 other articles by other scientists. If you have an impact factor of 45, that means on average every article in this journal is cited by 45 other people doing research. They built on that knowledge. This knowledge was built on around 45 times. So it's a vague and kind of rule of thumb way it's a rule of thumb way to establish how useful the research in a journal is to other scientists. If it's really useful, they're going to cite it a lot and build on it a lot, and so the impact factor would go up. And so if you're ever interested in applying to a journal, this is the general format you'd want to write your article in. Make sure you always check with the information for authors for any variations. And when you're shopping for journals that you might want to apply to or submit an article to, make sure you check out the impact factor to get a sense of the importance of the journal. Usually a good, and again, this is all a rule of thumb, but a good rule of thumb is the most valid journals will have an impact factor of at least 5. It's a rule of thumb. But in general, it's a sort of good reference point where if a journal has an impact factor of at least 5, then it's a worthwhile journal to send a submission to or to cite from yourself in your own research.